Good evening, sir. Am I audible?
Yes, you are Professor Abdul,
Yes.
if I'm not wrong.
Yes, sir. Sir, we will start officially. Good evening to everyone present over here. I hope you all had a refreshing break and are ready for another insightful day of learning or discussions. Welcome to the day 3 of Atal Online Faculty Development Program. For the past 2 days, we have explored key concepts and engaged in meaningful discussions. Today, we continue this journey with our today's chief guest, Dr. J. Jayapal, Assistant Professor, NIT Jamshedpur, on the topic landslides on the geological perspectives, recent lessons from the Wayanad landslide disasters. A short introduction about Dr. Jayapal, sir. Dr. Jayapal is presently working as Assistant Professor at National Institute of Technology, Jamshedpur, Jharkhand. He earned his BE degree in Civil Engineering from PSC College of Technology, Coimbatore, affiliated to Anna University in the year of 2007. He then worked as an engineer trainee at DLF Consultants, New Delhi for about 1 year and was also involved in the construction of IT Park in Manapakkam, Chennai. He then obtained his ME degree specialized in soil mechanics and foundation engineering from the College of Engineering, Guindy campus, Anna University by the year of 2010. Following this, he had worked as an assistant professor for a few years in the private engineering college and teaching different subjects in civil engineering. He then earned his PhD degree in civil engineering with a specialization in geotechnical engineering from Indian Institute of Technology, Madras by the year of 2021. Afterwards, he has joined as an institute postdoctoral fellowship at Indian Institute of Technology, Bombay, Mumbai, IIT Bombay before joining this current position. Dr. Jayapal has participated in several national and international geotechnical engineering conference during his research tenure. He is also won the Best Presenter Award at Indian Geotechnical Conference 2019 GeoIndust, organized by IGS Surat Chapter, NIT Surat, Gujarat. Very recently, he has won the Best Presenter Award at the Indian Geotechnical Conference 2024, organized by IGS Aurangabad Chapter, Maharashtra, and an awarded letter from the Springer with a worth of 75 euros. With this short introduction, I now welcome Dr. Jayapal sir to take over the session. Sir, now the platform is open to you. Before joining, sir, just a minute, sir. Before this, I'll request all the participants to switch on the camera for a short photograph. Thank you, participants. Sir, Jayapal sir, now the session is open to you. Thank you very much, sir, for accepting our invitation.
Thank you so much, Professor. I think you're Professor Abdul, right?
Yeah, sir. Myself, Dr. Abdul.
Okay. I have a little confusion with the names. Okay.
Yeah.
So thank you very much for the opportunity. So what I'm going to do is we have some bandwidth problem in my institute, so I'm going to switch off my video. Probably
Yes, sir,
continue this lecture by switching off my video. I'll, if necessary, and if you want, I'll continue with this video on. But I would suggest myself to switch off the camera. Why? Because we are having some bandwidth issue inside the institute. Anytime my internet may get cut off. So in that case, I have already instructed what to do. So please call me then and there, and please reach out to me as early as possible so that we don't miss on time. So with your permission, I'm just cutting off my camera, and then let me start proceeding with the presentation.
Yes, sir. You can go ahead, sir. Thank you, sir.
Yes, sir. Thank you. Sir, is my slide visible?
Yes, sir. It is visible, sir. Sir, full screen mode.
Yeah.
Sir.
Okay.
Yes, sir. It's moving also.
You can see the slides visible, right?
Yeah, slides is moving, sir. Yeah.
Okay, sir. Thank you so much. So,
Thank you, sir.
without wasting much of my time, I have around 115 slides close to. I have a limited time of around 1 hour 15 minutes, so I have to roll over the slides as quick as possible with the important points. So let me start this particular lecture by delivering the topic called Landslides on a Geological Perspective, Lessons from Wayanad Landslide 2024. So the presentation outline is going to be introduction, landslide morphology. Very slowly, we would classify the landslides, different types of landslides. We'll very slowly discuss what are the causes, and to some extent, we will discuss the corrections that are applied or how are we going to tackle this particular landslides. And finally, the core important topic, decoding Wayanad landslide that has happened in 2024 last year. So you can see this particular landslide. 1 minute. So you can see this particular landslide. For now, let us believe that this is a landslide, and we will revisit this particular slide sometime later when I discuss some critical points related to this particular landslide. So slowly we are going to define what is called as a landslide. We are going to classify it. We are going to discuss on the causes, as I said, and then we are going to discuss about the correction measures. So whatever the picture which you are seeing right now is a landslide that has happened in 1985 in a place called Puerto Rico. So this particular landslide has damaged around 120 houses and it has killed around close to 130 people. So it has triggered by extremely heavy rainfall was the comment made by different people. But actually, along with this heavy rainfall, what has happened is like let me keep that as a suspense. We will add on to this particular slide sometime later when I discuss about the multiple causes that are required to trigger a landslide. So as I said, landslide may be defined as a geological phenomena in which there could be a gradual or a sudden movement of soil or a rock mass under gravity. So it occurs because of two important forces, namely the driving forces as well as the resisting forces. So the driving forces are going to pull the soil or rock down the hill, which could be either equal or it can exceed the resisting forces, which are actually helping us, or it is going to hold the entire soil mass in that particular place. So the driving forces could be weight of soil, it could be rock acting parallel to the slope, weight which tries to rotate the material out of the slope, or it could be seismic shaking. So the resisting forces, which are called as the helping forces, probably we might have studied in the slope stability chapter in during our BTech or BE Civil. We could have discussed about Bishop's slope stability method, wherein you have this driving forces, you have this resisting forces. The same concept applies here also. The mechanics is going to be one and the same. So you see here, you have this resisting forces that prevents landslides, which are basically the strength of the slope, strength added by roots of trees, vegetation, buttressing lower part of the slope by etc. etc. So you see here landslides, we don't have specific causes, like they can occur either due to increase in the driving force or reduction of the resisting force. So it may occur in subduction complexes, volcanic arcs, transform faults, and intraplate settings like Himalayan regions. So particularly common in stream banks, you can see reservoir shorelines, you can have landslides along large lakes, sea coasts, etc. So they can occur anywhere on the earth where steep topographic slopes or where saturated material lies on the slopes ranging from a fraction to few degrees of inclination. So usually the velocity ranges from imperceptible, which means you'll not be able to find out whether you are in a landslide or whether the soil mass or the entire land mass is moving way high to around 22 kilometers per hour, 22 kmph. So you see the speed right from imperceptible to 22 kilometers per hour. So we have a separate type of classification based on the speed. Very recently, way back in 1998, I think close to 2000 people started classifying landslides based on the speeds. I would introduce you to that also in the due course. You can very well see this particular image that very well shows wherein you have all the probabilities or possibilities wherein a landslide can occur. So you see here, you have rock slides, you have landslides caused by poor road constructions, you have riverbank collapse that can also trigger some landslide close to the slopes. You can have debris flow in the stream channels. You can have landslides close to the habitats along the hilly areas. So you can see along the quarry or close to the quarry, you can have a rockfall that is expected. So it all happens because of natural reasons, very, very natural reasons. So we have created all the problems and we are trying to solve it, is my own opinion. You can see here, you can have landslides in the submarine areas as well. Okay, submarine landslides also happen. So, but it is not prominently seen, or it is not reported, like when we have earthquakes inside forest, when we have earthquakes inside some unoccupied areas, that goes unnoticed, that goes unreported, and we don't bother much about that. Okay, these are all very, very basic natural happenings that are and that will continue on time, on and on. So the problem here is, we are habitats, or we are creating the habitats in those areas. We are getting into all these kind of problems, and we are trying to solve it based on the science and technology, which is growing day by day, and with using computers, using mathematics, using mechanics, etc., etc. So if all these things happen in some areas where there is no population, we don't have to bother about this kind of disasters. I would not uh, talk more about the terminology related to disaster. Why? Because you're going to hear this term all along this FDP program continuously. So you see here, it is the movement of rock, debris, or earth down a slope. So in India and some countries, people use the term debris. Okay, the foreign people, or the actual pronunciation goes by debris. Okay, so alternatively, we will use both debris as well as debris. So you see here, when we speak about the morphology, so on top, I have given these icons there on top. It's like introduction, morphology, classification, causes, correction, and then the Wayanad landslide. So you can accordingly see that if I'm discussing on that particular topic, that particular icon goes green. Okay, in that way, you can identify that particular discussion is going on if you are missing my topic. So you can see that this is called as your morphology of landslides. So you have various parts that are associated, like crown, flank, surface of rupture, heads, minor scraps, transverse cracks, transverse ridges, radial cracks, toe, foot, toe of the surface of rupture. You can see the main body, you can see the rupture here. So these are all some important terms that you should remember, or you should have in your mind when you locate a landslide. So you have various important parts, as you see from this slide. So the main scarp, okay, this is basically the visible part of the surface of the rupture. So it is basically a steep surface of undisturbed ground at the upper part of the landslide. Okay, so the next important part is going to be your flank. So it is going to be an undisturbed or unplaced or undisplaced material adjacent to the sides of the rupture. Okay, so usually you represent this particular flank using compass directions: northeast, northwest, southeast, southwest. Or if you're indicating it using right and left directions, you have to give it according to the position of the crown. Okay, you have to give it according to the position of the crown. So crown is basically a practically undisplaced material still in place adjacent to the highest parts of the main scarp. Okay, so this is going to be your crown, and you have this main body. Okay, you have this main body. So this main body is going to be a part of the displaced material of the landslide that overlies the surface of the rupture between the main scarp. Okay, so these are all some of the important parts that we have to remember, and you can see this is called as your main scarp. And accordingly, based on the movements, you can very well see minor scarps also that has been triggered in this particular landslide. So the very important part is to classify the different types of movement. So we are calling every other aspect as landslides. So it is classified into different types based on type of movement, type of materials involved. So the material in the landslide could be either rock or soil. It could be both. So when it comes to rock, you have a different name. When it comes to soil, you have a different name. So when it comes to soil, it is described as earth. If it is composed of sand-sized or finer particles, you call it as earth, and you call it as a debris if it is composed of a coarser fragment. So based on the type of movement also, you have different types of names associated. As you see in this particular slide, you can have falls, you can have topples, you can have slides, you can have spreads, or you can have flows. Okay, so these landslides are described using two terms, okay, that refer to the material and movement. Okay, it refers to the material on one part, and the other part it refers to the movement. Okay, you see here you call it as rock fall, you call it as debris flow, and so forth. Okay, so you see here again, landslides may also form a complex failure encompassing both one or more type of movements. So that is called as your rock slides, okay, or debris flow, or combined rock slide and debris flow. So anything can happen as we are dealing with natural materials, not man-made materials, and that creates interest in geotechnical engineering, geology, as well as landslides. You see here, this is the earliest form of classification given by Varnas in 1978. So he has classified it based on the movement and based on the type of material. So you see here, you have both materials, bedrock as well as soils. So if the bedrock falls, you call it as a rock fall. When the soil is going to fall, if it is a coarse grained material, you call it as a debris fall. If it is fine grained, you call it as earth fall. When it comes to topples, you have rock topples, debris fall, earth topples. And then slides, you have two different types called as rotational and translational. You have rock slides, debris slides, and earth slides. When it comes to lateral spreads, you have rock and debris spreads and earth spreads. So flows, you have three different types of flow called as your rock flow, debris flow, and then your earth flow. When it comes to complex movement, it's a combination of either one or two or more types of movements that is possible with nature. So this is very, very important, and the most recent form of classification you see here, they have given 7 different velocity classes, okay, of classification of land, right from extremely slow to extremely rapid. I want you to notice the numbers here. You can see that typical velocity is 5 meter per second. You can see that it is 3 meter per minute, 1.8 meter per minute, 13 meters per month, 1.6 meters per year, and 15 millimeters per year, which means I already defined what is called as imperceptible. Okay, imperceptible means you will not be able to notice that without sensible instruments and construction methods, using unique construction methods. And you can see that in this case, when it is extremely rapid, 5 meters per second, you see here some lives are lost. You can see that catastrophe of major violence, buildings destroyed by the impact of displaced materials. You can have many deaths, and very importantly, your escape is unlikely. Okay, so this becomes an important classification based on the type of movement, right from class 1 to class 7. So let us very slowly enter into the classification. So you can have falls. A fall begins with the detachment of soil, or it could be rock, or it could be both, from a steep slope along the surface on which you can have little or no shear displacement. Okay, so for every other classification, I'm going to show you images to have a physical feel of how it happens or how it has happened. So you can possibly see how it could have happened, or possibly you can imagine how it could have happened there on the site. So the material subsequently it is going to either fall, or it is going to bounce, or it is going to roll. Okay, so it is going to be a rock fall. So these falls are going to be abrupt downward movements of the rock or the earth, or it could be both, that detach from steep slopes or cliffs. Okay, so the falling material usually strikes the lower slope at an angle less than the angle of fall, causing bouncing. Okay, so the falling mass may break, it can create an impact, it may begin to roll along the steeper slopes, or it may try to continue until the terrain flattens. So it's all because of gravity. So it all can happen because of the rock fall. So here you can see a very nice picture that you can very well visualize on the left part of the slide, which is basically a representation. And on the right part of the slide, on almost in the following slides, you can see on the left hand side, you can have a geological representation. And on the right hand side, you can see the real time happening of that particular fall or a landslide in common. So on the right hand side, you can see a rock fall that has occurred in USA way back in 2005. So they had closed this particular pathway or road which was there in Colorado for a number of weeks. So, and then probably you can notice some measures are taken to avoid the falling of these particular rocks. So this is called as your rock fall. So the next category comes called as your topple. A topple is recognized as a forward rotation out of a slope of a mass in either soil, or it could be rock, around a point or an axis below the center of gravity of the displaced mass. So that becomes your topple. So this toppling is sometimes driven by gravity. It is exerted by the weight of the material upslope from the displaced soil mass or the rock mass. Sometimes this toppling could be due to ice, it could be due to water in the cracks in the mass. So this topples can consist of debris, which could be a coarse material, it could be rocks or earth materials, which are basically fine grained. So the topples can be complex and it can be a composite also. So you identify the difference between the words called as complex and composite. You can think and appreciate how they have classified this kind of topples. Okay, so you see here, this is how the toppling happens. This is how the toppling happens along these portions. Pieces of rocks toppling one over the other, and on the right you can see block toppling in Canada. So the next category goes to be with the slides. A slide is basically a downward movement of a soil, or it could be a rock mass occurring on the surfaces of rupture on a relatively thin zone of intense shear strain. So when these landslides are created, you have all these shear stresses and shear strains that are generated that are pushing the soil mass or rock mass to slide. So because of that, you have these kind of category of landslides called as slides. Okay, so the volume of displacing material enlarges from one simple area of local failure. So you have varieties of landslides. Okay, so the very first category is going to be your rotational landslide, or landslide, which is basically a landslide on which you have the surface of rupture which is curved upward, or a spoon shaped type of landslide, and the slide movement is more or less a rotational one compared to that of transitional sliding about an axis, and which is parallel to the contour of the slope becomes your rotational landslide. I'm going to show you a picture sometime later. So before that, we will see what are all the contents of this rotational landslide. So this particular displaced mass, no, so it can move or it cannot move, or it may move as a relatively coherent mass along the rupture surface with very, very little internal deformation. Okay, so this is characteristic. This is basically a characteristic of this particular rotational landslide. So the head of the displaced material may move almost vertically upwards. So it can move vertically upwards, and the upper surface of the displaced material may either tilt backward towards the scarp, or it can tilt away from the scarp also. So the slide is going to be rotational. It has several parallel curved planes of movement. This is called as your slump. Okay, so in your slope stability analysis also, possibly you will identify the slip circles, right? So you will have a circular motion, or you will have identified, or you will identify what is the circular slip failure that can most probably happen along that particular path. So you can see several parallel curved planes that could be triggered because of this particular movement in that particular landslide. So you see here, this is the geological representation. Towards the right, you can see the photograph of a rotational landslide that has occurred in New Zealand. So on the top right, I have very clearly mentioned what is the scarp, what is the toe, and which is the axis of rotation. And this arrow marks will clearly say how is or how this rotational landslide could have happened in this particular area. So the next comes your translational landslide. So the mass in a translational landslide, it can move either out or down or outward along a relatively planar surface with very little rotational movement or backward tilting. So this is called as your translational landslide. So you don't have any curvical surfaces or arrangements or appearances over there. So this type of slide may progress over considerable distances if the surface of the rupture is sufficiently inclined. So this occurs majorly on some inclined surfaces, or the rupture surfaces. When it is inclined, you have a possibility of having a translational landslide. So this material in the slide may range from loose unconsolidated soils to extensive slabs of rock or both. So you can have loose sediments, unconsolidated soils, and extensive slabs of rock if they are present in that particular area or in that particular location. So these translation slides, usually they are common, and they are failing along geological discontinuities such as faults, joints, bedding surfaces, or the contact between your rocks and soils. So these geological discontinuities are very, very important, and this because of this geological discontinuities, you have the trigger of this translational landslides, namely the faults, joints, folds, bedding planes, bedding surfaces, fractures, etc. So in the northern environments, the slide may also move along the permafrost layer. So usually northern environments of India and in some countries like US, Canada, you can see a layer called as permafrost. Okay, we will see to that a little later with the images. So as you see here, you don't have a curvical rupture surface here. You can have only a translational slide. Okay, so a translational landslide that has occurred in 2001 in British Columbia, Canada. So you can see the translational slide. So this appears to be a circular surface, but still it is again a translational slide only. Okay. So the next category comes to be called as your spread. Okay, so this spread is an extension of a cursive rock, or it could be a rock mass combined. So this rock mass is nothing but an intact rock plus discontinuities with joints, folds, faults, fissures, etc. This combinedly called as your rock mass. So this is combined with a general subsidence of the fractured mass of the cursive material into softer underlying material. So you see here the spreads may result from liquefaction, or it could be due to flow or softer underlying materials. So if you have a harder material on top and a softer material at the bottom, you can very well experience a spread. So there are different varieties of spread, starting from your block spread, liquefaction spread, and lateral spread. So the mechanics is going to be, if one harder material is sitting on a softer material, you can most probably think about having a spread type of landslide that is most likely to occur in these areas. So as I said, you have lateral spreads. So you have a stronger rubber layer, a softer, weaker layer. You have rock spreads, the solids that ground extends and fractures, pulling away very slowly from stable ground and moving over a weaker layer without necessarily forming a recognizable surface of rupture is going to be called as your rock spread. So the softer and weaker unit, you could squeeze upward into the fractures that divides the extending layer into the blocks. And because of that, these lateral spreads are little dangerous. So you see here, the next category is called as your earth spread. So there's a very beautiful picture towards the bottom of the slide. You can very well see, you can have a softer layer at the bottom when you have a harder layer on the top. You can have this kind of earth spread type of failure. So the upper stable layer extends along a weaker underlying unit, so that has flowed following a liquefaction or plastic deformation. For the learned audience, I don't have to define what is called as liquefaction. So probably in all of your soil mechanics and then in your civil engineering, you might have been aware of what is a liquefaction kind of failure when the soil loses the entire shear strength and it starts flowing like a liquid. So if the weaker unit is relatively thick, the overriding fracture blocks may be subsiding into it or translate. It can rotate, it can disintegrate, it can liquefy, or even can flow. So you can see the masses of these pieces floating literally on the softer clay with water bearing silt and then your sand layers. Okay, so you can see this is called as your lateral spreads or your earth spreads. This is again a repeated picture to give you a feel of how this can happen in reality. So here you can have a very beautiful picture that is speaking about the lateral spread damage to a roadway as a result of 1989 Loma Prieta earthquake. Okay, so the earthquakes can also trigger this kind of landslides or slides. So you can very well see the lateral spread damage, and you can see the engineer inspecting how much is the depth and how much is the damage that has caused. So the next category is going to be called as your flows. You can have spatial continuous movement in which surfaces of shear, these are basically short-lived, closely spaced, and usually not preserved. So this type of failure is going to be flows. So this flows resemble to those of a viscous liquid. So you can think about the phenomenon of viscosity, which you have studied in your fluid mechanics. So when the viscosity increases, you can see the velocity of flow, and when the viscosity decreases, you can think about the velocity of flow. So often there is a gradation of change from slides to flows, depending on the water content, depending on mobility, depending upon the evolution of the movement. So based on this, your flows can differ and the categories can differ. You have debris flow. So you see here, it's a form of rapid mass movement in which you have this loose soils, rocks, organic matter combined with water to form a slurry-like substance that flows down the slope. So this is basically called as your debris flow. but sometimes it is inappropriately called as mudslides. Okay, so it is basically a debris flow only, not a mudslide. So people try to call this as a mudslide. Why? Because you have large quantities of fine materials that can be present in this particular flow, and because of which you indirectly call this as a mudslide rather than originally debris flow. Okay, so rotational, or it could be a translation slide, velocity and the internal mass which loses the cohesion or gains water, and it may evolve into a debris flow. Okay, so these are all the causes, or these are all the phenomena that can trigger this kind of debris flow. So you can have a dry flow also when there is no saturation. So when it comes to cohesionless sand, especially in the areas of especially in the dry areas, especially in the places where you don't have water, deserts close to the oceans, you can have this kind of sand flows. So you can see that debris flow can be very deadly, as they can be extremely rapid and may occur without any prior warning. Okay, so the one thing which I'm not touching upon is, like, for every other classification, we have triggering factors and we have monitoring mechanisms in landslide geotechnology or landslides. So I'm not touching upon that. Why? Because it could be a little advanced. So you see here, you have this debris flow. So this is very, very quick. You don't have any warning. You don't have any warning. Suddenly it's going to trigger and it's going to wipe out the entire area or the mass. So this is one of the picture that was taken in Venezuela way back in 1999, which was basically the worst natural disaster during 20th century. So several days of torrential rain has triggered this kind of mud flow, boulders and water. So this is basically a debris flow only. You can see the casualties. You can see 30,000 people were killed. Okay, 30,000 people were killed in this particular landslide. Okay, so you think about the importance of having a knowledge of this particular disaster, namely landslides, especially in relation to this debris flow. Apart from that, we have minor other varieties. So we'll see that also. So there is something called as leher. Okay, so this is basically an Indonesian term. So it is basically your volcanic debris flow only. So in the places where you have concentration of volcanoes, you can have volcanic mud flows, so which basically originate on the slopes of the volcanoes, and usually call them sometimes as debris flow also. So as I said, this is going to be an Indonesian term. It was an Indonesian term. So it is basically a windborne or an airborne deposit erupted from the volcanoes and the related debris. So apart from that, you have debris or debris avalanche. Okay, this avalanche are basically essentially large, extremely rapid, often open slope flows formed when an unstoppable flow, or when an unstoppable slope collapses, and the resulting fragmented debris is going to be very rapidly transported away from the slope. So probably you could have seen this debris avalanche or debris avalanche in some Hollywood movies. So in some cases, you can see snow and ice that will contribute to the movement. So in many of the Hollywood movies, in many of the James Bond movies, you could have seen the triggering of avalanche using gelatin sticks or using some other mechanisms. So this is basically a leher reported or represented by this Geological Society. This is what is called as your leher, and this is a real photograph of a leher caused by 1982 eruption of Mount St. Helens in Washington, USA. Okay, so this is what is called as your leher. So this is again a debris avalanche that has buried an entire village way back in Philippines. You see here, this was very well reported and um, picturized by Tokyo Geotechnical team. You can see the debris avalanche or debris avalanche. So this picture I had taken it from some Hollywood movies, wherein you have all these messages that are put. Okay, you can see that quiet avalanche area, silence, danger, etc., etc. These are all the places where you can where this avalanche can be triggered. So you can see a lot of Hollywood movies that are going to show you how an avalanche can be triggered. So then here you can see the images of the earth flow. Okay, so you can see the curvical path or the original place and how it has triggered. So on the right hand side, you can see the 1993, Limix landslide, which is basically an earth flow only in sensitive marine clays. So you can see that about 2.8 million tons of clay and silt, which were liquefied and flowed into the South National River Valley, damming the entire river. So you can see that 2.8 million tons of clay and silt. So in geotechnical engineering, what we study is like only the sands can liquefy, but even clays and silt on extreme events, on certain conditions, they can also liquefy. You can see the informations, clear informations, wherein how a clay and a silt can liquefy in geotechnical engineering, geotechnical earthquake engineering textbooks like Kramer. So as you see here, you can think about the quantum of soils, 2.8 million ton. So we have to remember that 1 ton is 1000 kg. You have to think 0.8 million tons of clay and silt, okay, flowing into the entire river. So the next one is called as your creep. Okay, so you can see that you have the representations indicated here with curved tree trunks. When you go to some hill stations, you can very well see the trunks curved, okay, curved tree trunks. In many of the hill stations, when you go, you can notice, you can see tilted poles also. You can see broken fences out of alignments. These are all some indications. These are all basically some indications of how the initial part of the landslide is usually starting, and then how is it proceeding. Okay, so the next, on the right hand side, you can see very clearly see how this creep is going to affect this particular area. So it is there in UK, so called as your chalk grasslands. So steep slopes of thin soil cover over marine chalk deposits develop a ribbed kind of pattern, ribbon kind of pattern on grass covered horizontal steps that are around 0.3 to 0.6 meter, 1 to 2 feet high. So, although subsequently made more distinct by cattle and sheep walking along them, these terraces, commonly known as sheep tracks, were formed by gradual creeping movement of soil downhill. So, you can see that these are all the creeping movements. Okay, so along this creeping movements, what they have said is like if you allow the cattle to pass through, it can also cause a pathway. So that is also mistakenly taken as a creep way. So these are all the things that are to be kept in mind for different types of landslides. So you see here, this is a very important picture that can tell you about what are all the other things that can trigger a landslide. So you see here towards the left, you can see original slope. You can have an active layer which is seasonally thawed, and you have permanently frozen icy sediments inside. Okay, so these are all inside this slope, inside this soil, which are permanently frozen. Okay, segregated ice bodies. Okay, at one particular point of time, if you trigger these kind of movement of ices because of n number of reasons, because of increase in temperature, because of forest fires, because of any other reasons, because of summer season, because of volcanoes, etc., etc. So what happens is like this ice starts melting, so it adds to the water content of this particular area, and because of the increase in water content, what happens, your slope starts failing. Okay, so this is called as your retrogressive thaw flow slide. Okay, so I would want to revisit very quickly this particular slide. As I told you, so you see here, this particular failure has happened, this particular failure has happened because of that particular thing which we have discussed right now only. So what happens is like because of the permafrost or because of the melting of all these ices inside, so this particular part has failed because of increase in water content along these areas, and due to which there is a separate type of landslide that has occurred because of freeze and thaw of the ice caps or ice layers that are laying inside this particular landmass. So this one, as I said, people said that it was because of heavy rainfall, and along with this particular heavy rainfall, what has happened is like they had a very huge leaking sewage pipe on top of this particular hill, and that particular leakage has quantified, or it has added up along with this particular heavy rainfall, and it has increased the water content of this entire soil mass or this area over a period of time, and on conducive situations the entire mass has failed, or the entire landslide has occurred in 1985. So let me very quickly continue the discussion. So you see here, we have the different classification of landslides based on failure. You can, I'm going to leave the slides for you. You can see all these images. So here you see the landslide map of India. You can very well see what are all the places in India that are susceptible to landslides, that are very, very susceptible to landslides. So you see here, these are all the portions that are close to Kashmir, close to Nepal, UP, Delhi, okay, along these regions. And towards the northeastern part, you can see the Seven Sisters from Assam, Tripura, Nagaland, all these areas. And here below your this Gujarat, you can see all these places. And you can see the legend here. It's like it's going to be very high on the red marked areas. It's going to be high probability on this kind of color. And you can see for an yellow color, you can see a medium trigger. And for low and very low, you can have these kind of places are susceptible to low and very low landslides. So let me revisit the codes of practice and agencies in India and abroad sometime later if I have time. So for now, let me proceed towards the causes. So you see here, you have different types of causes: physical causes, which are basically the triggering factors, and the natural causes. Okay, of course, we have artificial causes also. So let me go to this particular slide for you to very quickly identify the different causes. You can see that it is going to be a geological cause. You can have a morphological cause. You can have a hydrological cause. You can have a man-made cause or an artificial cause or an anthropogenic cause. You see here for geological causes, you have weathering, you can have chemical, physical, biological weathering that can trigger. And this is the most major one. Structures, stratification, orientation of different types of joints in that particular rocks can trigger your geological cause to have a natural cause that is susceptible for a landslide. For morphological cause, you can have topography, surface cover, land use, land cover, slope inclination, erosion, toe erosion, gully erosions. You can have subterranean solutions, piping, on slope failures due to deposition on the crust, and you can have tectonic activities, earthquake activities that will create an uplift or a movement, which is basically a morphological cause. You can see you can have hydrological causes also. Rainfall, intense rainfall, medium rainfall, different types of rainfall can cause can be detrimental, or it can cause there can be a causative factor for different types of landslides. So one of the reason why we had this Wayanad landslide is because of this intense rainfall only. So we can see it little later. So you can have the runoffs, infiltration, percolations, seepage, which are basically listed out under hydrological causes. You have anthropogenic causes also, like you can have encroachments, you can have unscientific cutting of hill slopes. So which means you're triggering the landslide to happen, which is already imbalanced because of nature. You can have deforestation, you can have unplanned drainage and sewerage system. You can have unplanned construction of roads in the hilly areas, ghat areas, or along the slopes that will artificially or anthropologically trigger this kind of landslides. Okay, so you see here, you can very well see you can have a stable slope which is natural, and because of these causal factors which I have discussed earlier, your stable slope becomes your marginally stable slope. Okay, and when it is marginally stable, you can have triggering factors. Okay, so this triggering factors will already, or it is going to cause your slope to fail. So the causes of landslides, you can have factors that make the slope vulnerable to failure. You can have factors that predisposes the slope to become unstable, like whatever we have discussed about the factors. You can see the landslide trigger. So the single event that finally initiate the landslide is going to be called as your landslide trigger. Okay, so these are all the important points that you should remember for causes and triggers of this particular landslide. So these are all the n number of causes that are responsible for generating or creating a landslide. So you see here, you can have rainfall, which is heavy or prolonged rainfall. For rainfall occurring over a short period of time, usually necessary to have very high rainfall intensities. You can have long duration rainfall events. You can have intensity of rainfall may only be moderate. So n number of reasons can trigger your landslide based on this rainfall category. So as I said, you have seismicity also, you can have toe excavation, and you can see inhabitation, you can have transport route development, cutting and filling in those areas that could trigger a landslide. So these are all some of the landslides that has happened in India. Okay, you can see in Uttarakhand in 2003. You can see the mudslides from Pune in 2014. You can have these landslides in Guwahati in 2012. So you can see along the Shillong road, you can see the rock fall. So you can see the landslide in Sonapur. You can see the mudslides that have happened in Arunachal Pradesh way back in 2013. Okay, these are all basically the examples of slope instability. Slope instability. So you can see the landslides beneath the Raj Bhavan in Guwahati way back in 2020, Assam. So these are all the causes that we have discussed till now. How do I correct it, or how am I going to correct this particular landslide, or what are all the ways and means as a human being, as an engineer, as a geotechnical engineer, or as a civil engineer, I have a probable chance of correcting it. Okay, I want you to draw your attention to this particular slide. You can see here, you have the slip surfaces here. If you remove a material from this head, it is going to reduce the driving force and increase the stability. Okay, so you see here, this is called as your ground surface. You can very well see how the slip surface can probably trigger or probably move. You can see the ground surface on top. You can have a slip surface here. If you're going to remove the material from the toe, it is going to reduce the resisting forces and it is going to reduce the stability. Okay. So on the right, you can see, in turn, if you're going to load this particular area applied at the head, so if this particular load is going to increase, so you can see that it's going to decrease the stability. So you're artificially going to trigger a landslide or a slope failure. So again, what happens if you're going to dump large amount of load at the toe in an engineering way? Okay, it is going to resist the forces and it is going to increase the stability. This is pure mechanics. This is going to be pure common sense, nothing great. So artificially or unknowingly, whatever the mistakes which you're doing in a non-engineered way, in a non-technical way, can trigger a landslide simply for no reason, without any civil engineering or without any engineering. So you see here, falling water table or pore water pressure increases when you have the resisting forces, and it is going to increase the stability. So when you have less water, you have less pore water pressure, less chances. When you have more water, you have more pore water pressure generation, and it is going to reduce your stability. So you can see these are all the illustrations given by US Geological Survey. So you can just go through their website and see what are all the basic mechanisms or the fundamentals that are required to be understood before you speak about landslide or landslide mitigation or landslide protection, etc., etc. So see here, you can see a special type of structure called as your rockfill buttress. Okay, you remove this kind of material, you put an artificial material called as your artificially filled material with aggregates, create a gabion or this rockfill buttress, and you start stabilizing this particular slope that is going to fail or that is most likely to fail. So you see here, you can have a creek channels. You can see a real-time structure of your creek channel using your rock lining, using your rocks over these places, and you can see the human movements here. So this was provided in USA. So apart from that, you can have crib walls. Okay, so you can create artificial structures using ripraps. Okay, so that you reduce the slope, okay, and increase the stability. So you can see the original gradient, and you can use all these artificial materials, natural materials, to artificially arrest the slope failure. So you can have a concrete crib type check dam. Okay, these are all some measures that are taken with low flow center section in South California and USA. You can see this real-time structure that has been provided. So apart from that, you can see a drainage trench. So the main causative factor of this particular landslide, if it is going to be water, you try to isolate it by providing a drainage. Okay, so you can have different names, you can use different materials. So you make sure that all the water is drained in either of the way, through the slope, away from the slope, around the slope, inside the slope, or wherever, in an engineering fashion, so that you isolate water from this particular soil or rock mass that is going to trigger a failure. Okay, you can see something called as your drain trenches. Okay, so this is provided in South Australia. You can have they have a separate geomechanics society that deals with landslide protection measures. So apart from that, as I said, you can have drainage pipes inside the slopes also. You can have if there is a tension crack, you make sure that you isolate water from this particular slope to have a stable slope literally, and you can see that the probable failure surface could be this a circular failure surface. You can have artificially injected horizontal drain pipes to keep away or to drain out the water that has been seeping out in this area. So the other things, you can have straw battles, you can have straws. Okay, so you can have rock benches, okay, provided along all these areas. You can see that I'm going to leave this PPT to you. You can see all these images. So these are all some natural means. You can have timber cribs. Okay, on the left hand side you can see the geological representation. On the right hand side you can see how in reality you can create this timber crib wall. So all these things are engineered way. You can have a design procedure separately for all these walls. So remember that this particular topic called as landslides is very, a big topic. It can never be covered in 1 hour. So I'm just giving you a glimpse of what is happening around the world. And all these things are engineered structures only. So if you take, you can have geosynthetics, which are basically artificially made synthetic materials. You can have geofabrics, geotextiles, geogrids, geonets, geofoams, okay, geocells, etc., to mitigate all these kind of falls. So you can see you can use natural and artificial materials as composite materials to tackle all these kind of failures. Okay, so I'm going to leave the slides for you. You can just go through that. So you can see here, you can have gabions. Gabions are basically you can have this kind of box type arrangements using steel wires in which you have large size aggregates, possibly 70 mm, 80 mm aggregates inside it, so that the main idea is to increase the weight of this particular structure so that it is resisting the slope movement or movement of this particular slope along this direction. Okay, and to keep away from water also, you can provide this kind of arrangements. Okay, so that you have artificial or natural drainage along this particular gabions or across this gradients, as the permeability is going to be very high. So these are all structures, or these are the structures which are very advantageous for draining out the soil to increase the weight of the structure in resisting the forces that are triggering this landslide over here. So apart from that, you can have pile walls. So you have n number of solutions. So this is one solution which people do all around the world, which is very famous, called as your planting vetivers. Okay, so this is more common in Tamil Nadu. People know what is called as vetiver. So it's a separate type of plant. You can see I have browsed to this particular vetiver.org. You can see these are all the countries people are using vetiver. Okay, known as known areas of distribution of vetiver grass, wherein there are active programs. Okay, to use this particular type of grass for increasing the soil stability. So you can see these particular images were taken in Congo, South Africa. Okay. So apart from that, you can have rock protection measures. Okay, gunneting, grouting, rock nets, wire meshes, artificial products, etc., etc. We have a number of products in geosynthetics to tackle all these rock wall protection. So you can have rock curtains also, that is going to control your rock falls in the problematic areas. So apart from that, this is again a simple common sense. So you increase the stability of this particular slope by providing benches, rock benches. Okay, so all these things you can very well see in any of your terrain journeys along a hill or across the hill. You can see the competent rocks only available on the tracks or close to the tracks. Okay, so you can see that they might have provided benching along these areas to increase the stability. So you can see these rocks getting dislodged by scaling and blasting. So what they do is like before planning for this railway tracks along this Ghat regions, in some regions where the track crosses all these hilly portions, what they do is like they scrap out all the unnecessary weak rocks that are lying on the top that can possibly slide along the track. So they make out all these rockfall protection measures, and then only they allow the rail traffic. So this is one type of measure. And apart from that, if you want to increase the stability, you can have rock anchors, rock bolting, similar concepts. You can see that you can have this rock anchors inclined at 45° plus 5/2 across deep depths close to 15 feet, 5 meters. So here they have shown it for 5 meters. It can have up till 15 or 20 meters also, as far as I know. So you can see shortcut operations that are famous, so that you allow this concrete to fill inside the voids of the rocks, so that it becomes an entire intact mass rather than a rock mass. So this is again a picture showing the rock bolting operation, just that it is like holding the rock in position so that it is not going to fall off because of any reason, any triggering reason. So apart from that, as I said, wildfires can also trigger this kind of landslides. So there are some arrangements, interestingly, in California, USA, so that they have made a pit kind of arrangement to accommodate all this sliding soil mass. Okay, so they have made this kind of arrangements. So this is basically an aerial photograph of a debris flow basin. They have created an artificial basin to accommodate all these debris flow substances inside this. So apart from that, you can have different types of retaining walls constructed close to the slopes. Okay, so this is in Japan. You can see how they have constructed using all these materials intelligently. So this is a slide that is going to tell you how to monitor a real-time landslide when it is most likely to be triggered using different types of instrumentations called as geophones, extensometers, okay, rain gauges. So nowadays we have a multi-module instrumentation setup, which is combinedly connected to a computer with different varieties of instrumentations with different modules, okay, to indicate which factor is going to dominate over the other. So you can see the direction of movements. You can see the shallow pore water pressure measurement using pore water pressure transducers. You can have a geophone that is going to monitor the movements. You can see the slope movement sensors. You can have rain gauges. Everything combined into a single module to identify or to alarm the people who are living close by when it comes to the trigger of the landslide, if possible. So I'm going to rule out all these slides. Why? Because these are all self-explanatory. You can just go through it when you're having time. So it is time for me to switch over to this particular topic called as the Wayanad landslide. So you can see multiple landslides. They were hitting Wayanad on July 30th, 2024. So this particular landslides, it started occurring around 2 a.m. on Thursday as per Hindu daily. So it has killed over 106 people. Several people are missing. Hundreds were stranded in that area. So there's a place called as Chural Mala, which is 4 kilometers away from Mundakai. Both are basically small towns surrounded by hills and plantations. So both locations are tourist locations or tourist attractions. You can have several resorts and homestays located there. So please notice this particular point, several resorts and homestays. So you see here, you can have a very neat picture of where the landslide has originated. You can see this particular called Mundakai. You can have this Chural Mala town. So this was updated on 6:30 p.m. July 30, 2024. So you can see that this is the path of failure. And apart from that, there are other reported secondary landslides, or the second landslide that has triggered at 4 p.m. 4 a.m. on the particular day itself. You can see that also. So you can see the devastations that has happened. So think about this particular boulder, think about this particular rock mass moving at a very high speed and hitting your building. Literally, you can see nothing is left over. Nothing is left over here. So you can see the devastations. So you can see the death tolls as per business standards. You can see NDTV, you can see Mint, you can see the business standards again here. So you can see 400 people casualty, more than that, death tolls, injuries greater than 200 people, missing 200 people. It's very sad. You can see that 310 hectares of farmland is being devastated, and the total property loss is around 281 crores. So you can see around 1,500 houses literally damaged, literally devastated, literally, you know, made useless because of this worst disaster. So if you look at the brief history of this particular Wayanad, you can see this has been a spot of landslides way back right from 1924. Right from 1924, this has been a spot of interest for this kind of landslides to happen. Right from 1924, you can see the different locations. So in 2007 itself, in 3 locations, they have had this particular landslide. And 2009, they have had occasionally, or in 3 different locations in Mupainad, Vellamunda, and then this Mepadi. In 2018, you had this Kurinchiarmala and Karincholamala. So in 2019, you had this landslide. It was reported in Putumala, and in 2024 in this Churalmala. So again, if you see the geotechnical aspects or geological aspects of this particular places, you can see the liquid limit, plastic limit, and you can see the chemical index of alteration, CIA. Okay, this is called as your chemical index of alteration. Though we don't have this concentration in this geotechnical engineering. So this is basically an index that is going to tell you how far is the weathering taking place in this particular place. You can see it is 89.1% in this place, 82.6%, 95.9, and 96.7. Higher the CIA, more the probability of weathering, or more the weathering that has happened. So very clear image that is going to tell you where the landslide has started, where it has moved, and where it has reached. Okay, you see the location here. It is around 1,993 meters above mean sea level, and you can see that 828 meters above mean sea level. It has traveled this much, distance, carrying all these sediments, rocks, boulders, different types of materials, and it has deposited in this particular place. If you cut open this particular place, okay, you can see that it's a word called Precambrian crystallines, Charnakite and Migmatite. I want you to note down these names of rocks, namely Charnakite and Migmatite. Okay, so if I have to speak about this Charnakite and Migmatite, these are basically of metamorphic origin. So you see here, both are subjected to high-grade metamorphism. So magmatite is basically a high-grade metamorphic rock which is present in different types of terrains. So you can see most of these migmatites, usually they are concentrated on Himalayas. You can find them in Norway, Canada, Finland, etc. And then you can see Charnakite. Okay, so there's an interesting history of this Charnakite. It is found worldwide from the Precambrian terrains. So it is mostly present in Eastern Ghats, Nilgiris, and it is also present in Sri Lanka, Madagascar, and the parts of Africa also. So it was first, coined in India, especially Chennai, after its discovery. Okay, this kind of Charnakite rock. So these are all type of metamorphic rocks. I don't have to teach you geology. You can very well see, or you can remember, or you can recollect what is called as rock cycle, what are all the different types of weak rocks that are there in sedimentary family as well as some metamorphic families. So this is basically a lithological map of Wayanad district. You can see the landslide points here. Okay, and this is the point of this debris flow. So already we have discussed about what is called as a debris flow. You can see the point. So this is basically a debris flow path. So you can see that these are all the types of rocks. And above all these types of rocks, you can see that only granite is very competent. So you can have the competent granites only here. And apart from that, you can have this only charnakites. Okay, charnakites and bigmatites. Okay. So this is again a location map of the landslide. Okay, that is there in Kerala. And because of this, you can see that this is the triggering portion. So this is based on this DEM, digital elevation model. So you can see that how it has triggered from this place to, this Vellarmala colony. You can see very well the road. You can see the elevations. You can see the debris flow path. Okay. So the very important image is this one. You can see on 30th and 31st July 2024, from the Indian Meteorological Department, they have given this rainfall data. So you can see here the Wayanad is there on top. So you can see this white portion means no rains. They had very high, very light rain. It is around 0.1 to 2.4 millimeters, almost on 31st July and 30th July. Very, very heavy rains or very heavy rains around 115.6 millimeters on 30th July from this place. You can have heavy rains also based on these indices. You can see because of this very heavy rains, all these collapses happened or all these landslide has been triggered. So the very next important thing that I want to show for this particular presentation is you can see or you can cut open the place where exactly the landslide has been triggered. You see here, this is the crown portion. And if you cut open this, landslide, you can see the charnakites and migmatites. And most importantly, you can see the joints here. Okay. In civil engineering, we teach students that joints are the place of weaknesses, not only in civil engineering, in real time also, wherever you have joints, these are all the planes or these are all the possibility of weakness. Even in life also, you see here, wherever you have joints, wherever you don't have any homogeneous relations, you can have problems associated. Okay, so you see here, this groundwater seepage has happened because of excessive runoff. Already this particular area is having weathered fragments. You can see this particular fall or rock fall has triggered or moved this particular segments all along this area to create this entire havoc. Okay, so you can see the water infiltrating down through joints and fractures. You can see the planar failure. You can see multiple joints dipping in the direction of slope. It is not only this joints, it is about the different set of joints, different orientation of joints, different position of joints, and the rock mass also forms a very important reason behind this particular disaster. So this is basically a digital elevation model that shows the slope. You can see the platform curvature, okay, and you can see the TWI. Okay, so I hope you know whether these particular terms or not. So TWI is basically your topographic wetness index, which is usually discussed in this digital elevation model. So TWI, which is basically a hydrological parameter derived from DEM. So it is going to quantify the potential of water that can accumulate in a given terrain. Okay, that can accumulate in a given terrain. So it is TWI is basically a function of slope. It is going to be a function of upstream contributing area also. So usually you use this TWI in hydrology, soil science, environmental modeling to assess the soil moisture distribution, and to some extent you can predict the wetland areas also. So if your TW index is very high, okay, if your this topographic wetness index is very high, so you can say that it indicates a water accumulation area in the form of valleys, floodplains, or wetlands. When it comes to low TWI values, you can say that these are all well-drained areas or steep areas with ridges and hilltops. Okay, so this TWI, though I'm not much competent in these areas, we can very well see that based on their reports, they are used in hydrological modeling. You can have soil moisture estimation, flood risk assessment. You can use them in landslide susceptibility mapping. You can use them in ecological and habitat studies. And you can calculate this TWI using your GIS tools like ArcGIS, QGIS, etc., etc. Okay. So you can see the overburden thickness, which is greater than 25 meters in the transition zone. You can see the narrow areas, which is less than 5 meters, and steep gorges that has been created, okay, developed in the post-landslide valley with very high vertical height greater than 10 meters. Okay, you see that this is 25 meters as indicated here. So this is your oblique aerial view of the landslide. You can see the location 1 and location 2 prior to the landslide, and after the landslides location 1 and location 2. You can see how far this area is literally moved from this place to this place. Okay, so the sediments moving the entire location from this place to this place in Choralmala. So again, you can see the aerial photograph of the accumulation before and accumulation after. So you can see that towards a distance of around 112 meters, you can see the entire portion or entire area getting dislodged because of the movement of all these materials. So this is again a lithological map that is going to clearly show all these images, that is very well explaining how this landslide could have happened. So you can have this landslide prone area. This is basically a lithological map. You can see the lineaments, streams, Charnakite group of rocks, Migmatite complex, and then your peninsular gneissic complexes. Okay, so you can see this is called as your sheared Migmatite. You can see the Charnakite outcrops here, and then the location of the cracks that are present there in the rocks and joints also. You can see the large boulder observed after the landslide. So these are all some rescuing operations. So let me finally come to some of the important conclusions. So you see here on 30th July 2024, a catastrophic landslide has hit. So you see here the formation mechanisms, characteristics, and impacts of all these landslides were widely investigated by n number of different researchers. You go to the research papers, you can have n number of research papers who have already started diagnosing all these types of landslides. You can see. So this particular region is highly susceptible right from 2018, 2020 on the same slope. And you can see that landslides have occurred in the neighboring regions with similar rainfall characteristics also. So this particular Mundakai Churalmala landslide, okay, it is initiated on a rockfall by planar failure, and then finally it has been converted using this debris flow type with a long runout distance of around 7 kilometers. So it was initiated by a rockfall, then followed by a debris flow. Okay. So the primary factors that were contributing were highly weathered and fractured geological conditions, slope morphological characteristics, and extreme rainfall. We have already seen how the rainfall has triggered, particularly rainfall exceeding 300 millimeters within 24 hours. So you have extreme rainfall events called as ERE here that has primarily triggered this particular landslide. So this has increased the pore water pressure. This has reduced the shear strength of the overburden, leading to slope failure. So, and the pre-existing debris that is already present in that particular landslide has actually, or it has significantly amplified this destructive impact. The source area of the landslide lies completely within the forested region, so no visible land use alterations were able to be located or identified based on that, or anthropogenic disturbances to some extent. Uh, you can see this is a summative slide that can tell you the why this Wayanad landslide has caused, because of rainfall, because of vast waters in the Chaliar River close by in that particular area, and the weakening of the force because of the excessive pore water pressure that were generated, quarrying, linear infrastructure development, construction activities, monocropping. They also say that because of that also this Wayanad's ecosystem has changed, and Wayanad has lost almost 60% of its forest between 1950 to 2018, and because of that, what has happened is like this landslide would have happened. So we have primary factors, secondary factors, and tertiary factors that has combinedly caused this particular landslide. So you can see 281 crores of loss. So this ISRO satellite has captured 8 kilometer or 7 to 8 kilometer long debris flow that has and a reactivated landslide with a scarp size of around 86,000 meters square. So you can see it is a combination of geological factors, it is a combination of geomorphological factors, climatic factors that has likely caused this particular landslide. So the disaster was a consequence of long-term impacts of climate change. So people started asking, was there any other reason? Yes, we have some important reasons related to climate change. You see here the Arabian Sea, because of the increase in temperature to 0.18 degrees centigrade per decade, right from 1960 to 2022, closely to 40 to 60 years, you can see because of the increase in 0.18 degrees centigrade per decade. For every 10 years, it is going to increase only 0.18 degrees centigrade. And because of that, they say that we are extremely getting affected because of this high-end rainfall and the cloud burst. You can see that the deforestation and quarrying have further destabilized the region's slopes between 1950 and 2018. 62% of the forest have been wiped out in this particular place. Already, I wanted you to note down that you have several resorts, you have several locations, authorized and unauthorized, that were reported by Kerala State disaster mitigation agencies in the daily newspapers as well as in the research papers. So you can see that scientists suggest that even the decayed tree roots, one particular point of time, this decayed tree roots also become reason why, because when they decay, they make the soil porous, and because of the soil getting porous, the soil permeability is increasing. That facilitates water infiltration. So more the water infiltration, higher the pore water pressure, lesser the shear strength, and because of that, your soil loses all the stability, creating a landslide. So apart from that, you can see Kerala's very high population density. It also demands innovative, sustainable land use policies and environmental management to prevent future disasters. So you can see steep altitude difference also is as one of the reasons behind why this kind of debris flow or why this kind of landslide has occurred. So all these conclusions were arrived not based on qualitative things, based on quantitative analysis, field observations, high resolution satellite imageries from ISRO, aerial photographs from remote sensing agencies, and rainfall data from Indian meteorological departments. So what are all the lessons to learn? So this is a very self-explanatory kind of image that I had taken from Australian Geomechanics Society. So these are basically poor hill practices. So if you do this, you will surely have a landslide. If you have good hillside practices like this, you can prevent landslides, or you can somehow tackle landslides. So you may not be able to avoid landslides. Why? Because these are all naturally occurring. Whatever anthropogenical causes, we can avoid those causes, but however, landslides will happen. Our responsibility or duty is to identify the location of these landslides and isolate or stay away from all these landslides to save our lives. So I have to very sincerely acknowledge Professor Arindam De from IIT Guwahati, wherein some slides I have observed or I have taken it from him. And there are some research papers I have read from Mr. Ratan Das that has been published in 2024 and ALHO et al. In 2024, based on the natural reasons, artificial reasons behind this landslide. And the other data and images I have taken from this US Geological Survey, International Consortium of Landslides, and Geological Survey of Canada. So you can use all these slides. I'm going to leave it for you. And you have to properly acknowledge all these people when you present it in some other place. And apart from that, I would like to conclude this presentation by saying a thank you to the organizers of KSR institutions from Tiruchengood. And I would like to take some questions. And you can also write to me through this email ID. You can take a Photoshop of this particular image. You can note down my WhatsApp number also. You can call me anytime through this WhatsApp number, or you can text me for any of the clarifications or for any of your doubts. So with this, let me formally conclude this talk. I'm sorry that I have taken the exact time, and I think it's time for you to join for the next lecture. I'm terribly sorry. If you have questions, you can just ask, or if not, you can write to me.
Thank you very much, sir, for your wonderful presentation on these landslides. I would like to participants, if you have any queries, now it's a session open to participants. If you have any queries, you can feel free to ask.
Yeah, you can just switch on your mic. You can directly talk to me.
Yes, sir.
That will be much better.
I have enabled the mic. Participants. Instead of participants, I have to call as professors. Is your time to
All of
have
them.
discussions? Yeah.
See, it's really difficult. I would, being on the other side, it's very difficult to attend college, coming back again home, sitting to
Yes,
this
sir.
kind
It's
of lectures and
difficult.
continuously hearing for 1 to 1.5 hours.
No, sir. The
And
session was interesting.
Okay, that could be interesting, but physically, the attention span for the participants or any human beings is only 40 minutes. Okay.
Yes.
That's why we have 1 hour classes, but still 1.5 hours. It's a bit tough from their side also. அவங்களுக்கும் கஷ்டமா தான் இருக்கு. காலேஜுக்கெல்லாம் போயிட்டு வந்துட்டு மறுபடியும் இங்கேயும் it will be tough. But no problem. They can write to me. Please share my WhatsApp number to them. I'm open for any type of questions, and I welcome you all to NIT Jamshedpur. And anytime you can come here. You have a wonderful campus here. Though our guest house has some limited possibilities, you can stay here close to the main campus. It's a nice city, steel city. And most importantly, for all the professors who are listening to me, please encourage your students to apply for MTech programs at NIT Jamshedpur with or without GATE score. For without GATE score, we are conducting examinations during August. You please see our websites. So you can encourage your students who are willing to do a master's program or a PhD or combinedly with or without a GATE score by looking into our website.
We will be asking them. Hope so. Participants, if you have any queries, or we will shift to our next session. Sir, I think they will be mailing to you if any queries is there, or they will,
Please.
yeah, or they will write to me, and I am going to hand over the questions to you, sir.
No problem.
I think
Please
that
do.
there are no
Someone is there.
queries,
Sir, please.
because we have given a very nice presentation regarding the landslides.
Okay.
So at present, many of them are using the synthetic aperture radar data to assess the land deformation modeling. Even a single centimeter of land movement, mass movement, can be predicted by using synthetic aperture radar.
Yes, sir, you can do that. We have technology with us. Something called, I don't know whether you're aware of this or not. So there is something called as digital twin. Digital twin means exactly making the entire structure as a twin. You artificially create a landslide and then you study. Okay. You see
that I know.
Okay, digital twin. You can make that. The problem here is how far I have time to alert the people so that I can avoid casualties. Every other data is there. I have technology with me. Okay, but nature does not wait. Nature does not wait. So I'll tell you one more information. Just to take 20 to 30 seconds. In Taiwan, you see here, the government is going to send you a message in your mobile saying that in another 3 minutes you're going to have a earthquake, or in another 2 minutes you're going to have an earthquake. So every other citizens, they'll go and hide themselves in some strong places under the table or anywhere else. ஸோ அந்த மாதிரி அவங்க இன்ஃபர்மேஷன் கொடுத்த உடனே எல்லாரும் ஓடி போய் ஒரு டேபிளுக்கு கீழேயோ அல்லது ஒரு இடத்துக்கு பக்கத்துலயே போய் ஒளிஞ்சுக்குவாங்க, அல்லது போய் சேஃபா.
But in our Indian condition, we are giving only alerts regarding to the rainfall.
Yes. But we need to travel a long distance. For this kind of technology and for this kind of alertness. At the end of the day, nobody should die. That's the role and that's the essence. யாருமே சாகக்கூடாது. அதுக்கு நம்ம என்ன பண்ணணுமோ அதை பண்ணணும்.
இல்ல சார், இப்ப நம்ம இந்தியன் கண்டிஷனுக்கு பாத்தீங்கன்னா, if those who are residing in the hilly areas, they couldn't able to access the telecommunication information.
இது ரொம்ப சிக்கலான கேள்வி. ஏன்னா சில இடங்கள்ல இந்தியன் கவர்மெண்ட் ஹில் ஏரியா கன்சர்வேஷன் அத்தாரிட்டின்னு இருக்கு, ஹாக்கான் இருக்கு, HACA, ஹில் ஏரியா கன்சர்வேஷன் அத்தாரிட்டி. they very clearly say that இந்த இடத்துல எல்லாம் நீங்க ஹேபிடேட்ஸ் வச்சிருக்க கூடாதுன்னு அவங்க ரொம்ப கிளியரா இன்ஃபர்மேஷன் கொடுத்துருக்காங்க, டேட்டா கொடுத்துருக்காங்க. பட் அதெல்லாம் மீறி நம்மளோட பேராசைக்கு, நம்மளுடைய தேவைக்கு அங்க வீட்டையோ அல்லது ஏதோ ஒரு ஹேபிடாட்டையோ அல்லது ஒரு ரிசார்ட்டையோ அல்லது ஒரு லொகேஷன் ஸ்பாட்டையோ நீங்க கட்டிக்கிட்டு அங்க அப்புறம் இந்த மாதிரி ட்ரிகர் ஆனதுக்கு அப்புறம் பிரயோஜனம் இல்லை. ஸோ ஃபாரின் கண்ட்ரீஸ்ல இதை எப்படி பாக்குறாங்கன்னா, ரூல் இஸ் அ ரூல். ஸோ தே மேக் ஷுர் தட் at least the rules are followed. They make sure that these are all the places where you should not have any habitats, or even if you have habitats, how you should make it in an engineered way. Idella they follow it rigidly, and because of that,
only problem is we do not have any stringent rules regarding this.
Yes. One of the reason is that there are a number of reasons. நிறைய காரணங்கள் இருக்கு. அதுல ஒரு காரணம் இதுவும்.
Okay. Thank you. You have given a very nice presentation.
Please. Thank you. Sorry, I'm taking more time for the next speaker. I think he will be waiting.
No problem, sir. He is also in line only, sir.
Okay. I don't know. I have seen.
Any other participants?
Sir, good evening, sir. This is Ramesh from K.S.Rangasamy College of Technology, sir. Sir, I have a doubt, sir. Your presentation is very nice, sir.
Thank you, sir.
Thank you, sir. Sir, I have a doubt. Recently, Tiruvannamalai, we have not expected.
Sir, I'm unable to hear you. Hello?
Yes, sir. Sorry, sir.
I think
Yeah, please.
So now here afterwards, we are afraid to go to temple side. The people will think how we are going to, because the people are very much devotees or illiterates like that.
Yes.
So many temples are near to mountainside. So you are saying that by that first ring earthquake, second ring some how we are going to give the alertness? So many people are not having the cell phone, and it's not a smart.
Yes, sir.
So many saints are there, like Tiruvannamalai, like holy places.
Yes. Your question is very, very apt. Your question is very, very apt. See, what I'm trying to say is, yes, we can go there, we can live there. But the problem is we should be ready for any of the negative event that is going to happen. Why? Because nature is not going to wait for you. Nature is not going to ask you. So the thing is like, see, what they do in foreign countries or what they do in some places is like Tokyo or in Japan, wherein that every other citizen of that particular country knows well about all these kind of disasters. They know very well how to react, what to do, what not to do. So let us say, for example, we take Tiruvannamalai or any place, say any X place, Y place. So if there is a more probable chance of having a disaster, the government should first of all plan for any of the negative event that can likely happen in that particular place. In India, we have என்னோட ஸ்லைட்லேயே வந்து பார்த்தீங்கன்னா கோட்ஸ் அண்ட் ப்ரொவிஷன்ஸில் கொடுத்துருக்குறேன். இந்தியாவில் என்னென்ன டைப் ஆஃப் ஆர்கனைசேஷன்ஸ் இருக்குது, வேர்ல்ட் லெவலில் என்னென்ன டைப் ஆஃப் ஆர்கனைசேஷன்ஸ் இருக்குது, அவங்கெல்லாம் என்னென்ன செட் ஆஃப் கைட்லைன்ஸ் கொடுத்துருக்காங்க, வாட் ஆர் ஆல் த செட் ஆஃப் கைட்லைன்ஸ் தட் ஆர் அவைலபிள் ஃபார் arresting or for mitigating this kind of problems. So if you follow that particular guidelines, you can stay anywhere, no problem. But the structures which you are going to build there for the people who are surviving there, they should be very competent. That is point number 1. Point number 2, அந்த ஸ்ட்ரக்சரோட காம்பிடன்ஸ் வந்து நேச்சரோட ஃபோர்ஸுக்கு கம்மியாக இருந்ததுன்னா தப்பிக்கலாம். இஃப் த நேச்சர் இட் செல்ஃப் இஸ் ஸோ க்ரூவல், இஃப் யூ ஹவ் டிசைன் த ஸ்ட்ரக்சர் ஃபார் 2 earthquake, 3 Richter earthquake, and if you have a 7.5 or 8.5, nobody can escape. There is no other solution to that. There is only one solution: avoid those places. அது ஃபைனலாக சொல்லுவோம். பட் you cannot avoid for multiple reasons. There may be a pilgrimage center, there may be some religious place, there may be some other important factor also. So there are n number of things to bring inside. It is again between science and nonsense. ரெண்டு தான்.
Sir, it's a very good explanation we are receiving from your speech, sir. Thank you for your everything, presentation and clearing all the doubts, sir. Thank you very much.
Thank you so much, Professor Ramesh. And anybody can write to me, can talk to me. Please share my information to all the participants. And I would love to come and interact with you on some other day, some other platform, on some other topic also. Thank you all so much.
Thank you.
If there are no questions, then I would like to formally stop sharing my, presentation.
Yes, sir.
I'd want to say a bye-bye to everyone.
Thank you, sir. In spite of
Thank
your
you,
busy
sir.
schedule, you are accepting.
Yes.
Yeah, someone
Any
is
other
there.
question? Yeah, please.
Some participants?
Yeah, there was some participant.
If any questions, we can write.
No problem. No problem. இப்போ அடுத்த ஸ்பீக்கருக்கு வந்து டைம் இருக்குன்னா I can take more questions also. No issues. I have time.
Professors, do you have any discussions? Okay, sir.
Okay. Shall we wind it up?
Yes, sir. We'll wind it up.
So I would like to formally thank KSR institutions, especially Professor Ramesh and Professor Abdul, for giving me this wonderful opportunity. And I would say all the best to all the participants. So sometime later, we'll conduct programs in NIT Jamshedpur also. Keep watching our websites, and you can write to me for any other faculty development programs also. Thank you so much. It was a wonderful learning from you and from the participants. Thank you. Thank you so much, sir. I'm stopping the presentation by unsharing my presentation. Thank you. Thank you
Okay,
so
sir.
much. அனைவருக்கும் நன்றி.
Thank you, sir. Thank you. Nandri, sir. Thank you.
Thank you. Thank you, sir.
So if you need, you can make it. Thank you. Yeah. Dear participants, thank you for your patient listening. We have completed our today's first session. Now we move on to our next section on the topic innovative technologies in disaster risk reduction. The session will be handled by architect Ratanamurthy, who is the chief architect of Sandbox and Company, Pochampally. Within 2 minutes, we will be starting our section. So Ratanamurthy, sir. Ratan, sir. Am I audible? Ratan, sir. Dear participants, wait for 2 more minutes. We will start our next section.
Okay, right.
Ratan, sir. Good evening, Ratan sir.
Good evening, sir Abdul sir.
Sir,
I'm sorry
kindly
to
go
say-
for the full screen, sir. No problem, sir.
the full screen. It's visible to everyone.
Screen is visible, but it is not in full screen mode. A PDF. I think it is visible, sir. So shall we start officially,
I've
sir?
gone through.
Yeah. So go to the first slide, sir. Screen is moving.
Yeah. It's visible in the full screen.
Still not it. So go from that slideshow or otherwise that like lower button. F5 or anything.
No, I done F5. It shows in me in full screen actually.
No. You escape from the F5, sir.
Okay.
At the right corner, you have that button also. Full screen mode. Screen share பண்ணிக்கிறீங்களா இல்ல
Screen
Windows
share பண்ணி
Windows share பண்ணீங்களா சார்? ஸ்கிரீன் தானே ஷேர்.
screen தான் ஷேர் பண்ணிருக்கேன்னு நினைக்கிறேன். Just a minute.
இப்போ அந்த screen only it has been shared. Unshare. Yeah. Now it is unshared. You again share it, sir.
So it's not happening actually. Entire window is not happening. It happens only a screen.
Yeah, you go for screen, sir. You go for screen.
Screen. Okay.
You go for the screen.
Entire screen, correct?
Yes, sir.
Now it's.
Yeah, your entire screen is visible, sir.
Okay. Now it's visible.
PPT. Yeah, PPT has been open. Yes, sir. It's now it is visible, sir.
Yeah.
Sorry
for.
No problem, sir. So just 1 minute, sir. With the formality, we will start.
Okay.
So one side, good evening to all the participants, professors. We will now move on to our next section on innovative technology in disaster risk reduction by architect V. Ratnamurthy. A short brief about our today's chief guest. More than 1.5 decades of academic and professional expertise were accumulated by architect Ratan V. Murthy. At Dr. MGR Deemed University in Chennai, he pursued a master's degree in landscape architecture after earning his bachelor degree in architecture from Adiman College of Engineering, which was a part of inaugural 2001 batch of Anna University Chennai. He had worked for Anna University for more than 17 years as a full-time faculty member from 2007 to 2023, holding position as lecturers to principal at several colleges in Tamil Nadu. He has been mentoring over 300 undergraduate students. He was recognized with prizes such as the Best Thesis Guidance Recognition and Best Anna University Examination Results Award for his 100%. In early 2008, he was also a member of the NATA questions preparation team. He had worked as a UG and PG University question paper settlers. Additionally, he has served as a faculty advisor for the student chapters of Indian Institute of Engineers and ISTE. In addition, he has provided consulting engineering services for residential and commercial building of the Osur chapter of the IIE. As a young architect, he worked for the Suresh and Sandeep Goyal Architect, New Delhi on projects including Ames Building, IIT Lucknow, and Tata Institute Aerospace Block. Since 2023, he had his own interior design studio in Pochampally, Tamil Nadu, and has finished over 30 projects. He enjoys sketching and traveling. He focuses on innovations and the adopting of new techniques in the field of architecture form the foundation of his contributions. Previously, he was the principal of the Kongu Architect Engineering College. With a short brief, now I call upon Dr. Ratan sir to take over the session. Ratan sir, the forum is open to you. Sir, before that, I would like to ask all the participants to switch on the camera for the video session. Participants, kindly switch on the camera. A photo session, short photo session. Sir, Ratan sir, screen and share பண்ணிடுங்க sir.
Yeah.
Photo வந்துரும். Yes, thank you, participants. So now its forum is open to you.
Thank you, sir. I'll just move on the presentation. Good evening to one and all, the professors and other participants who have been joined in this webinar. And before starting my section, is my gratitude to Mr. Abdul sir and Ramesh sir of KSR Engineering Department, KSR College of Technology, Autonomous, in the Department of Civil Engineering, providing such opportunity. And I've been there for the last section of Jayarajan service also. They'll be seen in talking of disaster management. The points which we have discussed by the earlier the expert team members will be keep sharing and keep continuing, because this particular disaster is unpredictable situation, and this happens based on the natural and human intervention. More focusedly, my topic which I'm going to cover of 30 slides will be purely on architecture and what are the precautions we are going to do for our human needs in the society. That is the primary which I'm going to take up. And the topic which I'm going to discuss here, it conclude with the 7. One is that everyone knows what is a disaster risk reduction, and we'll be coming across what are the technology of early warning system has been implemented in worldwide, and what the system is adopted in India also, and innovations in emergency response, data analytic of disaster management, case studies and practice of, and its application, future trends in disaster risk in technology, and conclusions. I'll move to the next slide. This particular slide which you're going to talk about, see, everyone knows, because being a professor is another part of in academics and non-academics, everyone knows that each technology, how it differs and how it meant in each needs. When you talk about places of disaster, disaster is a sudden change in our lifestyle. Okay, that's how we can conclude our disaster. There's a sudden change due to unaccepted of natural and man-made substance. So the man-made substance is always called as an architectural, just where we called as a planning aspects. We do a planning for our needs. We do a migration for our jobs. We unconditionally settlement in deep zones without knowing what is going to happen in the future. And there is a climatic process which also goes in the disaster. So this all disaster makes our lifestyle totally changed, and it also gives a warning to the future, and it also says that a signage to stop this particular aspect or this particular kind of development within our limitations of your ground level. Earlier in like 90s, 80s, 1990s, we used to come out disaster is not in the hugest scales. Maybe we come through across the knowledge through papers, we come through knowledge in terms of just communication orally. But recent trends, we have a lot of technology which says that anything happens in the world, we receive it through mobiles, we receive through a lot of news channels, we receive through a lot of like articles. So this is the important aspects we have to be come across, how this to the disaster, how to be deal, and what are the risk we are going to take up. The risk is also calculated in term amount of level where we have been affected in certain substances in terms of land, water, and air, etc. So the main of everyone knows that risk is unpredictable situations, and by knowing or by planning properly, we can just avoid risk factors. We cannot completely stop, or we cannot completely erect this particular aspect, but we can manage, or we can just give a controls. So what was Ramesh sir was given in the last section about Tirunamali is unpredictable movement in Tirunamali, which happens in a landslide. None of the people have been come to the conclusion that there will be a landslide in Tirunamala, because it's a central part of Tamil Nadu as a safer zone for kind of. But due to the heavy rain and due to other uncertain settlement happens, so there's a change. So this is how we have to come across and understand what can be done in terms of management, how to give a warning to the peoples, how to do a proper planning. Okay, so here, this how the management has to come. The final stage of management is that to be requiring the substance to the immediate lifestyle. So immediate lifestyle is nothing but example is Orissa. Whenever there is a cyclone happens, immediately people of that particular areas will, all the administrative officers will just move to the land wherever the disaster happens, or what are the causes been given by the risk factor given by the disaster, by in terms of flooding, in terms of earthquake, everything. This all to be required immediately, and it comes to the normal human life. So this 5 points, which is most important, we are going to travel in other slides also. So here we are going to have a lot of potential on damages. So this is how we are to come. This damage is basically on the community kind of settlement. It gives a huge warning to us. And we come about the next point is nothing but key elements of disaster risk. What is the key element? We are saying that we are not respond to that particularly, we are not immediately requiring what is happening, and we are not given any kind of precaution steps where the people are migrating from one zone to other zone. So migrating nothing but generally people move for their need of lifestyle. Actually, that how we develop or we expand our planning aspects in architecture also. When we do a master plans of every 5 years and every 10 years, when we do a master plan and take up in the scale level, we just understand how the people migrate from one zone to other zones and what kind of encroachment is happening around this particular spaces. So how to control, so the norms to be clearly indicates, and we should have a proper guidelines. This all reduce your disaster risk in your crucial area of the human life. So the encroaching advanced technology in terms of encroachment happens can be today we can come across by understanding of AI tools. We are coming about weather applications. We are coming about with photography, live photo sections by people uploading in the web medias and social medias. So this is how the encroachment can be controlled, and due to the sorry. Okay, sorry, I will come in. So there is a rapid response should be also given in that particular disaster. So Wayanad of other part of Kerala, or what are the zones which are affected by disasters, there's a lot of NGOs who immediately move, and there's a flood happens in Chennai. We have been gone through all this and through a lot of papers and videos, how the NGOs and other teams had rapidly response to safeguard the life of people in that particular zones affected by the flood. So India has already has such kind of systems which they come across the framework of a Disaster Management Act in 2005, and this particular team has adopted a new mitigations and new disaster preparations. Uh, Disaster preparation is also important fact well in advance, uh, to be more precise, to be controlled by the team members of individuality in all the aspects like air, fire, and water bases, navy bases, to be located in each locations and to know what is the emergency is required and move the people from particular zone to the next zone of a safeguarding. Here I want to just show you how this architecturally and structurally should be built, because this you have come across all this kind of planning aspects in early stages also in by the various speakers of this section. But still, being architecture, I am just going to show the slides which I think so. This screen is available to you. This talks about how the emergency architectural planning aspects to be done. So here there is a small images which uh, gives a clear understanding about how to design the spaces and how to withstand the structure in terms of winds and other typologies in terms of flooding everything. So when we have a wind typology like into 250 kps per wind withstand the flow, what kind of substance to be happen, how the planning should be done, in which direction we have to place our building, north or south or southwest. So these are the other important aspects to be designed in a building aspects. Okay, while taking this kind of consideration, mostly the reduction will given the first stages, then go for the next alternative, what is advanced technology we are going to adopt. This is how the first stage should be preliminary designed in terms of the taking of your location care, and in terms of shaping of building, we have various shapes. See how the shapes we have been regularly used. Each shape should be have a minimum intervals. So intervals in the sense leaving gap one block to next block, and we can have individual kind of shelters. Mostly this kind of squares and rectangles and long rectangles, L shapes are used in front of the seashore line, whereas the flood is happening in every seasonic periods of warning. And the huge cluster kind of arrangement we call the zigzag arrangement. This also avoids the majority of your wind patterns, and which gives a less damage to your structure. And talking about an important aspect of your roof, so what kind of roof on the hip roof, what to be a angle of your direction should be moved 25 to 40 degree, where if you have a over canopies, definitely there is a lifting chance of your building. So the next overhang should be minimized, and you can see this is a picture which pictorial representation how to be designed. I'm just showing my aroma over here. So when there's a canopy extended, and most of the profession it lifts the building, but just making a kind of edge line. When you're talking about edge line, maybe only the ridge just moves to the value point and keeps in the building line. It causes less kind of damages. It doesn't affect your building. So these are all the structural inputs. I'm just given the slide also. When you have just a time of understanding on the planning aspects, you can refer this particular slides. And I'm moving to the my slide back. So now the main point which we are coming about, risk reduction. So these are the risk reduction system which we have been adopting right now. One is called early warning systems, EDBS, geospatial technology risk assessment tool, disaster resilient infrastructure, social media and mobile technology, climate change, mitigation adaptation, coastal disaster recovery and reconstruction, community engagement and awareness, data collections and collaboration platforms, sustainable and eco-based approach. So what I told you in the earlier stage has been done in a pictorial representation. See, until we are not given any kind sign, or we are not given any kind of information to the common people. What says that what I want to represent is that who doesn't know this particular kind of practice, because we are educated, we know how to do a planning, we know how to control this, or we know how to prevent this. So all this prevention in higher authorities. So you can do a proper study and give guidelines to the government sectors, saying these are the areas of more risk factors when we do such kind of intervention by the human people in the society. So what I showed you a picture, I just given some kind of platforms like satellite images, geographical information, drones, and aerial monitoring. So a few guidelines which talk about how it moves on, because I'm moving on the faster sections to understand that after this section I want to have a kind of interaction, because this all theoretically known by us, but on practice way how we are going to help and how we are going to, I want to discuss with you all. I can take a few learnings from you also, because all this are just knowledge learning section. And this response also works on different aspects on how we are going to safeguard the main the central core. The central core is nothing but human life, economic, environmental, human rights, and democracy and social functionality. So this is a most important factor where we are going to talk about on reductions or for the risk on disasters. So government of India also has taken some kind of earlier stage precautions on disaster management. Like ISRO team is already involved in this particular aspect through satellites. They just give a signals, and they say through media, and this is going to happen to the particular space, like warning kind of sense. And there's a national database emerging systems serves iFlow Mumbai is a GPS support for the early warning floods and everything. And Gemini device provides a warning for the fishermen and oceans. So we come across all these technologies in our minor levels. So until we are not grouped together, until we are not discussing these particular aspects of disasters going to happen, how to prepare ourselves, so we cannot prevent anything. So here is all a chattable formations. Only humans are making such kind of disasters, like 80% of chances are done by humans and 20% are done by natural formations. So here the 80 and 20 differs by the typology, how that particular space or the particular element is used. Okay, used in the sense where we are going to put our risk factors at higher level. So until we are not doing any kind of brainstorming to the committees of local communities, so here the risk will be higher level. So as being a professors and being other kind of organization heads, so we have to educate how to prevent, how to make some kind of a solution to the local authorities to prevent all the disaster happens in the zones. So stimulations also comes to your reality how we are going to play in what I'm the picture, which gives a preliminary explanations about what I've talked this particular sites. And there's other NGOs who is already involved in this disaster risk reductions. Tata Consultancy is there, Info Foundation is there, WI India is there. See, all this gives a clear picture, warnings, symbols, and warning technologies given to the government sectors to prevent themselves well in advance. And this government will initiate this kind of information forward with higher officials and communicate to the lower people to work it from that zone. So this successful implementation of here, there's a lot of shortcomings which we are going to talk about. People lives in the disaster prone zone, high risk areas. So we have to understand insufficient understanding and awareness of the current in futures and multi hazards and systematic risk, and risk remains unknown, unestimated. So this is the first where we have to understand and we have to educate. So the second outcomes in terms of prevention is a better measures to prevent the risk reduction is not risk or not to be addressed properly. Communities and infrastructures of lacks of that is nothing but your local zones to be properly guidelined. uh, we have other important factors of disaster strikes. The disaster strikes nothing but you'll be more about lack of facilities in particular zones suddenly moving to like in terms of roadway connectivity, in terms of air connectivity. So this all comes into force. Then how this disaster strikes will help the people to move out from that zones is the most important. How you're going to give a crucial thinking on this aspect should be done by team members of evaluation in terms of brainstorming. And how you're going to implement these impacts and long-term impacts to be reduced and reconstruct and give a rehabilitation in particular zones to be normally gone through. And other important factors is other breaking of cycle of disasters and crisis trials in the continuous and occurs research actions in DRM is also a stage of across the sections, and here content is most important factors. So The findings are the important points where we have to understand what we are going to take up in innovations. What are the important innovation to be drafted in the market, and it derives the growth and the response to the evaluation of the customer demands and technology achievements. So integration of technology investment and research development also improves your current products and goes to the new technologies to for the purchase of new markets needs. So I want to recall the content what we have gone through, a small video kind of presentation. So I think so. You have been got an insight. Not about how the risk management is being carried forwarded by the various NGOs and other government sectors. Now I think so. My slides has been come to an end part. So if there is any kind of questionnaire which I want to clarify, I put forward to the participants of professors and the team members. Thank you. Abdul Bari sir. Hello.
Sir, yes, sir.
Yeah, sir.
Am I
Now I have
audible,
been
sir?
come to my end of my slide. So if there is any kind of questionnaire which I give, see, totally I give an insight about how this is disaster risk has been made and what are the government is doing right now.
Yes, sir. Yes, sir. So now the time for questionnaire section. So the participants, you can ask the questions.
Participants, sir, am I audible? Ratan sir?
Yeah, you are audible, sir. I'll come to the main screen.
Yes, sir. பண்ணிடுறேன். Participants will wait for few more minutes. The guest is rejoined. Some issues in network.
Hello, it's audible?
Yes, sir.
Hello?
Audible, sir.
Yeah,
Audible,
yeah.
sir.
Sorry. I'll just, yeah, yeah.
So just a
I'll
minute. I
try
will make
to.
you as a
So
presenter
there's
again.
other,
Yeah, sir. I have made you as presenter. You can go ahead, sir.
okay. Thank you. Sorry.
I have
Uh,
made you as a
see,
presenter.
there's other, I think so. My screen is visible. I think so. Correct.
Yes, sir.
So this is a short video which to understand about the more 10 points of risk.
Is this audio is there for this video?
I am audible. I think so.
So you are audible, but for that video.
If it's a, sir, it's audible.
So yeah, it's audible, sir.
Thank you, sir.
Sir, the video, sir, YouTube video is not audible. You have a full audio for that YouTube video. So if you go for that mic option, there you can change it. So now you run the video, sir.
It's audible.
No, sir.
No.
So mic
Just
mic
give me.
optionல உங்க இதை மாத்தணும். ஸ்பீக்கர்ஸ் இருக்கும் அது வந்துட்டு மாத்தி.
Okay, mic option. More audio settings.
Mic, you go for the speakers.
Speaker.
I think you are having with your headphone.
Yeah, it's headphone.
Yeah. இப்போ பாருங்க, இப்போ ரன் பண்ணுங்க சார். அதெல்லாம் ஒன்றும் வீடியோ ஒன்றும் ப்ராப்ளம் இல்லை சார்.
இல்ல கேட்கலீங்களா சார்?
இல்லை சார், கேட்கல சார், கேட்கல.
Just 2 minutes.
சார் உங்க ஹெட்ஃபோன் ரிமூவ் பண்ணிட்டு வீடியோ அப்படியே ரன் பண்ணி விடுங்க, கரெக்டாக இருக்கும். Yeah, now you put the video.
இப்போ கேக்குதா சார்?
Yeah.
ப்ளே
Now
பண்ணிட்டேங்க.
it's okay. Play.
I'll just start from the starting.
Yes, sir.
Hello.
Yes, sir.
Yeah, sir. Now I just completed my video section, which has a deep understanding about how it works on that.
Okay, sir. Okay, sir. Dear participants, now the forum is open to you. If you have any queries, you can ask. Participants, sir, I have just one query, sir.
Yeah, please, sir.
Sir, actually, how we relate your architectural point of view into the disaster, sir? Since in buildings.
Yeah, sure, sure. So actually, when you come about the disaster management,
Sir, voice is not clear, sir. Now you can hang on your.
based
Sir,
on
voice is
your
not clear, sir.
human. It's audible.
Sir, audible, sir. Voice
Now
is
it's
not
audible.
clear. Yeah. Now it's audible, sir. Yeah.
Yeah. Okay. I'll come with the question what you have just asked. How this disaster has been implemented in architectural part. So the architectural, when you talk about architectural part, we develop a master plan and we sit with that other NGOs, team members, and higher officials to understand the human interventions, how the human intervention has been stepped forward on the movement of hazards, which to be prevented by planning aspects. So the first scenario is just having a boundaries setup is a point we have to be defined, and we should keep the resource as it is to not disturb, like in terms of deforestation or excess use of the resources in that particular, that prevents your the first part, like a risk from the disaster. The second thing is that while planning any kind of building is naturally sometimes there's a disaster happens due to the rain, everything. The structure where I built around is that it should be stable. What the videos and it gives a clear picture. It should be stable in terms of the erection. What is the size of the column? What is the length and breadth of the space should be designed, and what type of roof? If it's in the flooded portions, the columns or the posts which should be erected are erected, and the function should be spaces should be in a W6. An unflooded zone, it should be at the ground level. On the flooded zones or the flooded season, this particular spaces can be covered by the water bodies. The people will move from lower part to the first floor level. So this how the structures has been designed in Assam's for the flooding aspect by the architect in earlier stage, and this still implements on the seashore lines. So this is the second point we will be looking to the consideration. The third scenario of controlling in terms of like prevention is better than cure. We have to implement the system strong by guidelines. So strong guidelines says that creating boundaries of each natural hazards and human-made hazards clear and should be controlled. So taking all this into point aspects in architecturally, the master plan will gives a silent figures how to move forward or move further level of development within the limit of your acceptance of human needs. I think so. I put up your question clearly. Hello.
Yes, sir. Yes, sir. Thank you very much, sir, for your nice. So one more question from one of the faculty, sir.
Sir, good evening, sir. Sir, is audible, sir?
Please, sir. Please.
Sir, what are the primary causes of landslides in Wayanad, sir?
Good evening, sir. Please, good evening, sir.
Yes, sir. Yes. What are the primary causes of landslides in Wayanad, sir? Is audible, sir?
Sir, see, when you're talking about the line, yes, yeah, audible, sir. I think so. Sir. the primary causes which Jaipal sir has a landslide. Jaipal sir has given a pictorial presentation on his slide where I was in the meeting also. Say this when you talk about hill settlement regions, the important factor is that we are interpreted to the agricultural planning level. We divide into various like highest grade of peak levels, lower grade of peak levels, and medium grade of peak levels. Where the medium, it says that the flat surfaces will be accommodated by the humans, but provided with a thick vegetation. When the steep level kind of planning principles, definitely because of any disturbance happens in planning in terms of erecting the columns, and due to the natural hazards like rain or other, maybe the other aspects like a wind, definitely the unpredicted kind of situations, the building will be get slided from top to the lower portions. That's the reason we can see that every seasons on monsoon season, we can see that in Ooty and Wayanad or any kind of field regions, there will be landslide will happens because of this scenarios. The main architectural part are NGOs who take this kind of consideration. Planting a tree is a first priority to stop this landslide on the zones of your the surfaces, zones of the surfaces on the steep zones. So wherever the steep zones, they start planting the structures. The first principal level of stopping of land is your tree. So when you start deforestation or move forward in terms of hilly kind of development because of aesthetical purpose or kind of nature required by the human needs, we are disturbing the natural concern. So this landslide will be against our the natural cause about the surfaces. So we taking of precaution. What I recalling you is that going with the guidelines is one first primary sector. Second, planting the trees on the light side is a secondary important factors. Third, what kind of structures you are going to take up. See, when you're talking about a huge column, the kind of erections, so definitely we cannot go with such kind of file structures to be stand for a G+1 or G structures. So you should know the alternate surfaces like playing the graduals the playing with the slopey structures. So this is how we can prevent your natural slidings.
Sir, is audible, sir?
Yeah, please. Yeah, audible, sir.
So the deforestation is the main causes for that Wayanad slide, sir. Is it?
Definitely deforestation and the human intervention, sir. We are
Human.
moving towards the human interventions. Human interventions is nothing but a new kind of see, people moves without binding. See, when there is a land of the slopey structures, we dumping of your surfaces into a flat structures, creating a flat plateau on the slopey regions. So without understanding the process, how we take up, that's all the process.
Yes, sir. Yes, sir. So, how does the climatic change in that play in increasing landslide occurrence in Kerala, sir? So, any specific climatic change, sir, is also causes for landslide, sir? Sir, is audible, sir?
Sir, definitely can change. Yeah, it's audible, sir.
It's
It's
possible,
audible,
sir.
When you talk about the climatic, sir,
Change.
it's I'm audible on your section. Correct. It's audible.
Yes, sir. Yes, sir. It's audible,
Hello.
sir. It's audible, sir.
Yeah, sir. Yeah. Sir, I'll continue, sir. So the
Okay.
climatic also comes to the important factors. See,
Yes.
without the climatic understanding or without the climatic changes, like for example, there's a heavy rains. There was a sir was asking about Tirunamalai. It was unpredictable situations. No one knows that what happens because the structure is already a muddy kind of zones. and with lot of small stone molecules which are already under the damage conditions. When there is a sudden kind of waters or heavy rain falls, so it definitely reaches to the plateau surfaces. So this causes on a rainy seasons or any kind of pressures or any kind of changes on the mountain region, any kind of mountain region or any kind of slope. So definitely there will be sliding happens. In spite we having a kind of protection of barricades like trees or any kind of thick vegetations around the surfaces will also causes a landslide because of climatic changes. Maybe the wind or maybe the rain.
Thank you, sir. Thank you for your wonderful explanation. And thank you for your very good presentation on today's topic. That is given detail about the innovation technologies which has been taken in the disaster risks. Participants, do you have any queries?
Thank you.
Participants, do you have any queries? Okay, sir. With an official, we will close today's session.
Thank you, Abdul sir, and
Thank you, sir. Thank you. In spite of your busy schedule, you came to us.
thank you, sir.
So now we are officially closing this session, sir. Thank you, sir.
Thank you. Bye.
Thank you.
Thank you, sir.